Good day everyone. Today I'm going to present to you our good product named as Starcello straw. Before I start my presentation, I would like to show you a few pictures that I found online, which is the picture of petroleum based straw. It's all look beautiful and attractive and full of various of shape and color. But after that, where does this straw went to? Then I googled the destiny of the straw, and this is what I get. Without the complex statistic and research, we all can know from the picture that the straw have created a lot of problems to our environment, especially in the ocean, and endangering the sea creature. So, in order to solve this problem, my group and I, we are trying our best by inventing this product, Starcello straw, and hopefully one day it can replace the petroleum based straw in the future and stop the damage of the plastic straw that had done to our environment. We want the straw, but not at the cost of our environment. We want a biodegradable straw which can degrade after a few weeks. We want a straw which is environmental friendly to our environment, and this is our straw, Starcello straw. What is the novelty of our straw? Our straw is processed by using dipping process, which is a very common and simple process that can be found in the industry. Next, our product is fully made up by natural material, for example, starch, nanocellulose, and water. Besides that, our straw is low cost and non-toxic since it was made up by natural material. Lastly, and the most important thing is our straw is highly biodegradable and at the same time provide a good strength as a straw. Next, why are we choosing oil palm anti-fruit branch OPEFB to extract cellulose? This is because OPEFB is abundant and readily available. Our country, Malaysia, is one of the biggest suppliers of palm oil country. Malaysia produces about half of the world palm oil production. However, after palm oil production, the palm oil waste were left with no economic value other than energy generation. Due to discourage of incineration of palm oil waste, OPEFB has created a major disposal problem. Thus, our team is trying to expand the efficiency of using OPEFB for filler in our product as the promising way to obtain more energy from palm oil waste and also solve the agricultural disposal problem in our country. Besides that, OPEFB also contains high percentage of cellulose and it is inexpensive in Malaysia. Besides that, we are choosing nanocellulose as our filler because it is lightweight and high contact surface, which can lead to better dispersion in TPS metric compared to micron size cellulose. Other than that, many studies also show that incorporated nanocellulose can improve the strength of TPS and also provide good strength for our product as straw. Furthermore, nanocellulose also can reduce water absorption of our product. Meanwhile, we use nanocellulose because it has antimicrobial properties which can help to reuse our straw up to 2 times. Lastly, we choose nanocellulose as our filler because it is natural material and can be biodegradable in natural environment without leaving any toxic residue. We use starch as the material of our straw because it is highly biodegradable and non-toxic during disposal, and it can be used as the food source for animal and fertilizer for plant after usage. Next, starch as a metric because starch has high compatibility with nanocellulose by forming strong hydrogen bonding with each other. Lastly, we choose starch as our straw material because it is abundant and low cost, which is benefit for commercialization. For our cost, the material that we use were cornstarch, nanocellulose, glycerol, and water, and their cost for producing 10 Starcello straw are shown in table. Meanwhile, we also calculated the electricity they used to produce our straw through the power usage of equipment. By including the labor and overhead, we calculated the cost of 10 Starcello straw is 7.21 ringgit Malaysia, which means that 1 Starcello costs about 0.72 ringgit Malaysia. Although our straw will be slightly high cost due to lab scale production, but our straw can be used up to 2 times due to antimicrobial properties of nanocellulose. After finish using our straw can be used as food for animal and fertilizer for plant as disposal method. Besides, if our straw were commercialized and put in mass production, it will definitely decrease the cost of our straw. Next, I will show the process to produce nanocellulose fiber from raw material. Figure 1 shows the raw oil empty fruit branch fiber obtained from supplier, which is long and untreated fiber. After that, the fiber will be crushed into a very short and powder form fiber, which is shown in the figure 2. The crushed fiber will be sheathed in order to obtain uniform and micron size fiber. Then, the uniform micron size OPEFB fiber, which shown in the figure 3, will undergo alkaline treatment and bleaching treatment. For alkaline treatment, the OPEFB fiber will be treated with 4% NaOH solution for 1 hour to remove hemicellulose and lignin to expose the contact surface of cellulose. Meanwhile, for bleaching process, the OPEFB fiber will be treated with sodium chloride for 3 times until a white and clean cellulose obtained as shown in the figure 4. Next, for acid hydrolysis, OPEFB cellulose will undergo acid hydrolysis in 65% sulfuric acid solution at 45 degrees Celsius for 1 hour under stirring condition. Then, the nanocellulose will be repeated centrifuged and washed by distilled water until the pH of the nanocellulose suspension obtains pH 7. After that, the nanocellulose will be homogenized by using high-speed stirrer to disperse the nanocellulose. The nanocellulose suspension will be dried in the oven and nanocellulose in powder form will be obtained. For production of our product, Starcello straw, the cornstarch was added into the distilled water in the ratio 1:20. After that, glycerol was added into the starch solution as the plasticizer for the starch. Then, nanocellulose will be added into the mixture. The mixture was kept stirring at temperature 70 degrees for 45 minutes until a gel form of starch was obtained. Then, the gas rod was dipped into the TPS and dried in the oven, and this process will be repeated until the desired thickness of Starcello straw was formed on the gas rod. The Starcello straw was demolded from the gas rod and the Starcello straw is ready to be used. Lastly, although our product outlook may not look as nice as the petroleum-based straw, but our product is invented to replace the petroleum-based straw in order to solve the problem of disposal millions of plastic straw which ended up in the ocean. And we also like to provide a sustainability material for our future generation. At the same time, we are also trying to maximize the usage of palm oil waste, which mostly end up as a waste in the landfill. Our product is highly potential to be commercialized as a bio-based and biodegradable drinking straw.